Hello, we are going to talk about matrices of order 3. So by definition, what is a matrix? Matrix. A matrix is a rectangular arrangement of numbers, symbols, expressions such that are arranged in rows and columns. So the rectangular arrangement, we represent a matrix by using this symbol, or we can use the brackets. So we say this is a matrix, but the elements here, we put elements. These elements here, we say A, B, C, D, E, F. These are the elements of our matrix. So these elements can be numbers, they can be expressions, they can be symbols, but arranged in rows and columns. That is what we call a matrix. So where do we use the matrix? So uses of a matrix. The matrix are used by programmers. The programmers use the matrix for coding. They use matrix for coding. They use matrix for encrypting a message. Encrypting means that they transform a data such that that data cannot be accessed by an authorized user. So they use, those programmers, they use matrix and their inverses for coding and encrypting messages. So also, where do we apply the matrix? The matrix are applied in the study of the electric circuits. It's also applied in the quantum mechanics or optics. That is also another application of matrices. A message is made up of a sequence of numbers in a binary format for communication, and it follows a coding theory for solving. We solve problems using matrices. The order of the matrix. The next one is the order of the matrix. So the matrix are denoted using elements I and J. We say our matrix A is equal to Aij, where this I is representing row and J is representing column. So if you have our matrix A, which is Aij, where I is the column, I is a row and J is a column, where I is from 1, 2, 3 up to the number of rows. J equals to 1, 2, 3, and so on and so forth. So when we represent our matrix here, we say our matrix A equals to Aij using this bracket. It means that you can either write a matrix of order 2. Order 2 means that it is a matrix which has 2 rows and 2 columns. The matrix of order 3 means that it is a matrix of 3 rows and 3 columns. So when we say A equals A1, 1, this is an element. It is an element on the first row on the first column. This is A1, 2. This is an element on the first row on the second column. This is 1, 3. This is the element on the first row on the third column. When we say A21, this is an element on the second row on the first column. A22, the second row, the second column. A23, this one is the second row. This one is the second row. This one is the third. It's 3, 2, 3, 3. Is it? This one is the first column, the first row. this is the second row. It is 2, here it is 2, 3. Now, this one is the first column, the second column, this one is the third column. So, this matrix is a matrix of order 2. If we need a matrix of order 3, we say it is A12, A1, A11 here, A12, A13. This is A21, A22, A23. This is an element A31, A32, A33. This means that it is an element on the third row on the third column. This is an element on the third row on the second column. This one is an element on the third row on the first column. So this is how we denote a matrix. Example, when you check on this, this is a matrix of order 2. It has the 2 rows and 2 columns. Here, this is another type of a matrix. This one, it has only 1 row and it has 3 columns. That's why they call it a 1 by 3 matrix. A 1 by 3 matrix, 1 by 3 means that it has 1 row and 3 columns. There is 1 by 1. A 1 by 1 is a point because it has only 1 row and 1 column. So this one is a 3 by 3 matrix. 3 by 3 matrix. 3 by 3 matrix. Meaning that it has, this one is the first row, this is the second row, this is the third row, but this is the first column, the second column, and the third column. That means that it is a 3 by 3 matrix. Types of matrix. We have what we call a square matrix. A square matrix is a matrix whereby the number of rows and the number of columns are equal. When the number of rows are equal to the number of columns, we say that matrix is a square matrix. When I equals to j, the number of rows equals to the number of columns, we say that matrix is a column matrix. A square matrix. So when we have 2, 3, 4, 5, this one is a 2 by 2 matrix. The number of rows, we have 2 rows and we have 2 columns. That is a square matrix. When we also have B as 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also another matrix. It has, this is the first row, the second, the third. It has 3 rows. By the first one, the second, the third. It is a 3 by 3 matrix. This one also is called a square matrix. So, within a matrix, there is what we call the reading elements . When we have our matrix here, we have for example, when we take this one, order of a 3 matrix. So this one, 1, -2, 4, 2, 3, 2, 5, 7, and 0. This element here, it is on the first row, on the first column. So this one is on the first row on the second column. So these elements here, these elements, they are called reading elements, or that one is called reading diagonal. Then these elements here, they are called secondary diagonal, or it is called minor diagonal. This one is called minor diagonal, and this one is called the major diagonal, which means in the matrix we have two diagonals. We have the minor diagonal and the major diagonal. The major diagonal is also called the leading diagonal. So we have this matrix here. We have our matrix A, which is A, B, C. A prime, B prime, C prime. A prime prime, B prime prime, C prime prime. These elements here, this one, they are the elements which are in the major diagonal or the leading diagonal. Elements here, these are called the minor diagonal. This one is called secondary diagonal, and this one is called primary diagonal, the one we call the leading diagonal of the matrix. We have also what we call a row matrix. A row matrix is a matrix which is composed of a single row. So when we take an example of this, a single row, which means we have 2, 3. This is 2, 3 like this one. This is a matrix. It has one row. This matrix A is the one we call a row matrix. But this one, if you want to donate this one, this matrix is A is 1 by 2. 1 by 2 means that it has one row and 2 columns. This matrix which has one row and 2 columns is called a row matrix. We have what we call a column matrix. Is a matrix which is composed of one column. So this one has 2, 3. This is a matrix. It has only one column. So this matrix is 2 by what? 2 by 1. So it has 2 rows and 1 column. So this matrix which has 1 column is called a column matrix. We have what we call the Nil Matrix. This a matrix which is called a Nil Matrix is a matrix where all the elements within that matrix are zeros. So for example, when we take our matrix A, which is 0, 0, 0, 0, this one is a 2 by 2 matrix, but all the elements here are zeros. That matrix is called a Nil matrix. When we take B, we have 0, 0, 0, this is a 3 by 3 matrix, but all the elements are zeros. We call that matrix a Nil matrix. There is what we call an identity matrix. Is a square matrix whose elements are 0 except the elements of the main diagonal. We have talked about the main diagonal, the leading diagonal. The leading diagonal is the same as the main diagonal. So, the one we call an identity matrix is a matrix where the main diagonal elements are not 0. The rest of the elements are zeros. So, when we call our matrix A, this is 1, 0, 0, 1. This is what we call an identity matrix. An identity matrix, you see the reading what? The reading diagonal here. All the elements we have here are not equal to 0. And it's equal to 1. This one is called a reading, an identity matrix. We have our matrix, we have 1, 0, 0, 0, 1, 0. We have 0, 0, 1. This is also another matrix. This matrix, you see these elements on the main diagonal. They are not equal to 0. So if the elements that are in the leading diagonal or the main diagonal are not equal to 0 and they are equal to 1, we call that matrix to be called the identity the identity matrix. So we have what we call lower triangular matrix. The lower triangular matrix is a matrix whose nil elements except the elements of the main diagonal. That's except the elements on the main diagonal. So what we call the lower triangular, we have a matrix. Let's take an example of 2, 5, negative 4, 0, 3, 1, 0, 0, 7. Here, this is 2, 3, 5 are the elements in the main diagonal. So if the elements below the main diagonal are zeros, we call that matrix to be lower triangular matrix. This one, this element here, 0 here, 0 here, this element, if they are below the reading diagonal, if they are below the main diagonal, if they are zeros, we call that matrix to be lower triangular matrix. If the zeros here, this one 0, they are above the main diagonal, we call that matrix to be called upper triangular matrix. Example is this. We can have 2, 0, 0, 5, 3, 0, 1, let's say 1, 2, 7, like this. This is a matrix C. So this 2, 3, 7 are called the reading elements. If the elements which are above the reading elements are zeros, we call this matrix to be called upper triangular matrix. When the zeros are below the main diagonal, we call it a lower triangular matrix. So we have what we call a singular matrix. Singular matrix. A matrix is said to be a singular matrix if and only if the determinant of that matrix is equal to 0. When we have a matrix A, when 2, 4, 5, 6, and you find the determinant of our matrix A, and you find that the determinant of that matrix is 0, we call that matrix to be a singular matrix. So we have a singular matrix, we have a lower triangular matrix, we have upper triangular matrix, we have identity matrix, Nil matrix, column matrix, row matrix as the types of matrices. We have operation. Operation means addition, subtraction, multiplication, and division of the matrices. When we have a matrix, let me say take a matrix A with A, B, C, D. This is a matrix A. When we have a matrix B as E, F, G, H, this one is a 2 by 2 matrix. It has 2 rows and 2 columns. This is also a 2 by 2 matrix. But when you take A plus B, we are going to get another matrix. The matrix we are going to have is supposed to be in the same order because we add the matrix of similar orders. We cannot take a matrix of order 2, we add it to the matrix of order 3. Because we add the elements which are in the same position. When we take A plus B, we have A, B, C, D, plus E, F, G, H. So this A, it is an element on the first row, on the first column. This E is an element on the first row, on the second column of the second matrix. We add the elements which are located in the same position. So this means that A plus B will be equal to A plus E, B plus F, C plus G, and D plus H. So when we add two matrices, we are supposed to get another matrix. That sum of two matrices is going to give us also a matrix of the same order with the matrices that we have added. When we take a simple example, if our matrix A is 2, 4, 5, negative 2, 1, 0, 5, 1, 1. This is a matrix of order 3. We have our matrix B, which is 3, 1, 3, 2, 2, negative 1. We have 3 here, 1, 1. This is also another matrix. When we add them together, what are we going to get? We are going to get the summation of A plus B. When you add A plus B, when you take A plus B, it will be 2, negative 2, 5, 4, 1, 1, 5, 0, 1, plus 3, 1, 3, 2, 2, negative 1, 3, 1, 1. I have told you that when we are adding a matrix, they are supposed to be a square matrix. They are supposed to be having the same order. So this is a 3 by 3 matrix. We are adding it to a 3 by 3 matrix. So we add the elements of the first matrix to the elements of the second matrix, but they are supposed to be in the same position. That is to say, here we are taking 2 plus 3, which is 5. Negative 2 plus 1, which is negative 1. 5 plus 3, which is 8. 4 plus 2, which is 6. 1 plus 2, which is 3. 1 plus negative 1, which is 0. 5 plus 3, this one is 8. 0 plus 1, this is 1. 1 plus 1, it's 2. So this one is another matrix which is the summation of A and B. You see that this matrix we have here is also a 3 by 3 matrix. This one was a 3 by 3 matrix. This one also was a 3 by 3 matrix. When you add two matrices, we get another matrix of order what? Of order 3. So the scalar multiplication. A scalar multiplication, it's we take a number, we multiply it by a matrix. Scalar multiplication. Let's say K belongs to the set of real number, and we want to multiply this the scalar number. We want to multiply this one to a matrix. When we have a matrix A with A, B, C, D, E, F, it's a matrix A, and we want to say Ka. That means that it's K, a scalar number, times A, B, C, D, E, F. When you multiply a matrix by a scalar number, we get another matrix, which is a multiple of that scalar number. So we are getting each element is going to be multiplied by the scalar number. So we are getting Ka, Kb, Kc, Kd, Ke, and Kf. This is our Ka. It means that each element in that matrix is going to be multiplied by that scalar number. When you take an example, if A equals to 2, 4, 5, 6, find 3A. 3A means that you are going to get our 3, you multiply it by our matrix A. That means that our 3A will be equal to 3 times our matrix, which is 2, 5 and 4, 6. It means that each element in this matrix is going to be multiplied by 3. And we are getting 3 times 2, 6, 3 times 5, 15, 3 times 4, 12, 3 times 6, this one is 18. This is our matrix 3A. When we multiply a matrix by a scalar number, we are getting another matrix. So it can, this one I have used order 2, but you can multiply using any order. It can be order 2, order 3, order 4. It can be in any order. So that is using scalar multiplication. Let's have an example here. This is an example. This is our matrix A. This matrix is a 3 by 3 matrix. We have B here. It is also a 3 by 3 matrix. They are telling us to find A plus B. You can try this because this A is a square matrix of order 3. This one is also a square matrix of order 3. So here we need A minus B. A minus B, A minus B. This is the same as A plus negative B. It means that here you can take negative 1 times B, or it means that each element in B, they are going to be multiplied by our negative 1, such that this one acquires this negative sign. You can try this example to find A plus B and A minus B. Another example is, we have this example. So they are telling us consider the matrices A, B, and C. You're going first of all to check, are they in the same order? Are they a 3 by 3 matrix? Is A a 3 by 3? Is B a 3 by 3? C is 3 by 3. Are they in the same order? If yes, you can take A plus 3B. You're going first of all to get 3 times B, that is a scalar multiplication. We have talked about it. Then you remember how to add the matrices. Find 2A minus B, then A plus negative A. If you take A plus negative A, what are you getting? And they're saying, give any comment. A plus B and B plus A, what are you observing? So they say from the results, give your comment. You remember here about the types of matrices. We have talked about the Nil Matrix, and I have told you that that is a matrix where all the elements are 0. Here you will tell me whether it is commutative or it's not. Here you're going to find A plus. You find this, you find this, then you tell me this is a property of associative, then you interchange the laws and column of the given matrix. You change. The one which is a law becomes a column. The one which was a column becomes a law. Here you're going to prove here the comment, is it associative? Here you're going to tell me, is it commutative? So try to do the examples and you tell me the answers here. So we have another example here. Still it is about the operation of addition, subtraction, and scalar multiplication. We have A, we have B, we have C. Try A minus B. A plus B minus 2C. 2A minus B plus C. So another one, that's the end. So see you next time.